Hi everyone, today we're looking at limits in a point and at infinity to be precise. And we're going to compare the function f of x, which is 5x plus x squared over x, compared to g of x, which is just 5 plus x. Now g of x I can easily sketch, because that's the function that goes like this. It's a straight line. And the height there is 5, and here the x-intercept is -5. That's g of x. F of x looks much more difficult, but if we look at it closely, this x there and one of those x's here and that x there, they cancel out. So f of x is really close to g of x, and in fact it's also going to be a straight line. But there's a problem, because for f of x, x is not allowed to be 0. Now how does that affect the graph? And how do we know what happens when x approaches 0? And that's what the limits are all about. What happens when x approaches 0? What does the function value do? Now we will study that by taking the limit. So we're going to investigate the limit of x approaching 0 of 5x plus x squared all over x. Now that is the limit of x approaching 0. And now I'm going to actually cancel out those x's. So there, of 5 plus x. Now here in this instance, if x is a 0, there's a problem. Here, if x is a 0, there's no problem at all. So I know that when x approaches 0, this x here approaches a 0, so the whole function approaches 5. So the answer is 5. Now for the graph of the function, that means that right at the point of 5, there is a hole in the function. So I'm going now to talk about not g of x, but f of x. So let me try to, no, that's a bit much. So for f of x, there is a hole in the function, because x equals 0 doesn't exist. It cannot happen. So the function is a line all the way up until this point here, and there's a gap, and then it goes on again on the other side. There's a little hole there. But we also know that when x approaches 0, from that side or from that side, the function value does indeed approach 5 from the top or from the bottom. So that's the first one. And so this limit in a point just works very similar to, for instance, let's do another example. The limit of x approaches 2 of x squared. Well, there's no problem at all with x squared, and if x approaches 2, then x squared will approach 2 squared, which is 4. Easy as that. Or perhaps the limit of x approaching 3 of x squared take 9 over x take 3. See, there is a problem, because when x would be a 3, the bottom would be 0, not allowed. So what happens when x approaches 3? So you near that problem, you approach that problem. Well, what happens is, it is the limit of x approaching 3, x plus 3, x take 3, I'm factorizing the top, and the bottom is still there, and I realize, hey, this cancels out. So it's actually the limit of x approaching 3 of x plus 3, which is 3 and 3, 6. That means for this function here, x squared take 9 over x take 3, when x approaches 3, the function value approaches 6. Now the second part of this is limits in infinity. And that has to do with horizontal asymptotes. For instance, when f of x is 2x plus 3 over x take 4, you know that there's going to be a vertical asymptote, but there might also be a horizontal asymptote when x approaches infinity. G of x as well, there might be a vertical asymptote, but there's also a horizontal asymptote when x approaches infinity. So horizontal asymptotes, x approaches infinity or negative infinity. So let's have a look. For instance, it's the limit of x approaching infinity of 2x plus 3 over x take 4, which is the limit of x approaching infinity. And now I'm going to do something that you may have seen before. I'm going to divide every term that I have here, this one, that one, that one, that one. I'm going to divide it by the highest power of x. So my 2x will become a 2. The 3 is a 3 over x. X over x is 1. And negative 4 is negative 4 over x. I can do that because I divided the top by x of the fraction, and I divided the bottom of the fraction by x. So there's no issue, this is legal. But now I can clearly see that if x approaches infinity, then 3 over x here, with x infinity, that will approach 0. And just as well, this will approach 0. So the outcome here is that the limit of x approaching infinity is 2 over 1, which is 2. So there's a horizontal asymptote at y equals 2. Just similar, the limit of x approaching infinity for x squared take 3x plus 2 over 1 plus x squared is the limit of x approaching infinity. Again, divide everything by the highest power of x, which is x squared here. So it's 1 take 3 over x plus 2 over x squared all over 1 over x squared plus 1. And again, we will see this is going to be 0, that's going to be 0, that's going to be 0. So the outcome is 1 over 1 is 1. The horizontal asymptote is y equals 1.